So today we're going to be looking at something that I've wanted to do for about 30 years. We're going to be looking at overloading a cable reel when it's fully wound up. It won't take much. Now, I know that some of you won't be interested in the side effects that we have where we're going to be trying to pop the 13 amp fuse. So what I've done is I've clipped the video down, and you'll be able to find the chapters where you can just get straight to the explosions, so you don't have to listen to me waffle on for a little bit. For the rest of you that want to listen, what we have here is just a standard domestic 13 amp cable reel, the one you can buy down at Home Base or any of the still running DIY shops. I just thought I'd reference one that is out of business now. The one that we've got is, as you can see on the board, is 13 amps. That's because a UK plug top can only take 13 amps because it holds a 13 amp fuse. We've got it set up so that I've got a 2.5 because, as we know from previous videos, we'll be able to overload a 2.5 safely. They can hold 20 amps. We should be able to get pretty much the whole load, 3000 watts, easily pumping down there, because that's only going to be about 13 amps. We're going to plug this extension reel. That's why we've got it set up as we have now. We're going to run the 2.5 down to, sorry to turn that way, down to the test rig, and we're going to have all the heaters on. And then what we'll do is we're going to do 2 tests or 3 tests. We're going to run the extension reel all the way out, have it fully reeled. It's 15 meters, so it's not massive. But what that'll do is we're going to see if, first off, the thermal cutout goes or the 13 amp fuse, and can we put more than 13 amps down the plug top before it pops? Because, as I say, 13 amps is the small fuse inside, and it will just be doing what it's supposed to do, and that's stopping overload and stopping a fire. We, however, are trying to do the opposite. So what we're going to do is cut the socket or the plug top off, connect it straight into our Henley blocks, and then we're going to overload it with as much as we can with these 4, possibly having to take out the thermal resistant, the thermal cutout, because that's just going to play havoc with everything as we go on. So literally we're just going to unreel this a little bit. Oh, no, actually, we're going to unreel the whole thing. So I'll be back in 2 seconds. A lot easier. Right. $15 meters doesn't even look that much. All right, so we've got 15 meters plugged in there. Got the heaters plugged in. So we've got 2 heaters plugged in. So let's go 3000 watts and 2000 watts, because then we can do just the fan, can't we? So we're back. We have fully unwound the extension reel, full 15 meters. It doesn't look very much on the floor. And then we've plugged in 2 heaters. We've got the 3000 watt heater and the 2000 watt heater, but the 2000 watt heater allows us to put just the fan on, so we can tip it just over the 13 amps, see if we can get to 14, maybe 15 amps before the fuse blows. It might just pop perfectly on 13, but it'll be interesting to see. Or, as I said before, the thermal cutout will kick out, and therefore we'll have to just take it to bits and remove the thermal overload. We will go straight to the 13 amps. So let's have a look at that. So we've gone straight in at about 12.3 amps. We knew that wasn't going to pop it because it's got a 13 amp fuse. So everything's working perfectly fine. You'd be perfectly safe. This is rated fully unwound at 3120 watts, which is more or less about 14 amps. So you would expect the fuse to go before any damage or heat occurred to the cable. We'll now put, oh, it's not here now, is it? So we'll now put the fan on. So the fan is absolutely lackluster, so that was fruitless. Right, let's go straight for one heat then. So now 16.39 amps. Well, we've got a 13 amp fuse in this plug top. So again, from our findings, we now know that a 13 amp fuse doesn't always pop at 13 amps. This isn't unusual to me. I am an electrician, so I know that there's a tolerance. Normally, if something is spiked with 13 amps, there's a high chance from cold that it would pop. but because we've done it slowly or slower, I wouldn't have expected to take 16 though. Realistically, if you wanted something to pop and be protected at 13, it is warm. I will say it is a little bit warm, but you'd expect it to pop pretty much at 14. So that already is surprising. We've got 16, nearly 17 amps pumping through. Let's go for heat 2. So now we have 20 amps down a 13 amp plug top. 20 amps down a 13. I'm actually very surprised. I thought, I can't even say, I know the K extension reels are old, but I can't even say that the fuse isn't going because it's old, because that's just not how fuses work. Yeah, so I'm baffled. Right, okay, so I wasn't expecting that. 20 amps down a 13 amp plug top. This could be a video in itself. How much can it take before a plug top pops? Let's get another heater. 2 secs. Let me just get another heater. We'll just go for another big one. We won't dick around and go for anything small. I'll make sure it's off to start with. I'd like to hope at some point the 13 amp, you'd like to think you're protected by a 13 amp fuse. Heat 1. 27 amps. Just go back to the plug top. How hot is that plug top right now? Oh, you can see, look at the fuse. You can actually see the fuse glowing through through the plug top. So it wouldn't be long before the plug, it has just popped. So the heat has just gone off. We're back down to 0. So, can you remember what amperage it was? 20, 22? 22, or something along those lines. I'll probably put it just here. So we now know, again, another experiment complete. We can tick that one off. 13 amp plug top can take about 22 amps before it pops if you do it slowly. It didn't take it for very long. So it was once it got hotter, and that plug top is very hot now. So once it got hotter, it obviously increased the resistance, and then it just gave up the ghost. But I am surprised. I'm disappointed in the 13 amp plug top. What I'm going to do now, we're going to, and again, the thermal overload didn't even kick out. I had 3 heaters running off that, and the thermal overload might be old, but I wouldn't have expected that to fail. What we will do is I will now take the actual plug top off. If it's not hot, probably damaging. No, we've got metal clad sockets, so it's not going to damage them. You can feel a little bit of heat dissipation on there. What we're going to do now is we're going to cut the plug top off and connect it straight into the Henley blocks. And then the interesting part comes. So it was getting a little bit warm. We should have done a cable temperature really, but never mind. What we're going to do is we're going to wind the cable onto this reel. Well, not on video because it's so slow and clunky. But what happens then is we get 2 effects come into play. We get, firstly, resistive losses. Because the cable is on top of itself, and this is the bit I told people to skip, because the cable is on top of itself, the heat struggles to dissipate. So as you can imagine, you've got cables and they're bunched, and where we had the one cable, that's hot, where we had the one cable and we had all the air flowing over it, that obviously was the best case scenario of heat dissipation. We're going to do a video where we do it through some insulation, and then the heat dissipation won't be very good. Hopefully we'll go to show, but that'll be another day. With resistive losses, the cable struggles to lose. Obviously, it's gaining heat from the one next to it, it's throwing heat at the one next to it, and it's just a constant battle. So it basically just creates a big, massive ball of heat that can't escape. The second one is proximity effect. Very similar, but this is more of an electromagnetic effect. And what that actually does is, as you have 2 cables basically on top of each other, because they're obviously wound and they're in a coil, you have an electromagnetic effect that as the alternating current is alternating, obviously, and going down the cable and pulsing, it's causing an electromagnetic field to pulse onto that cable there. What that actually does is that draws the current that's going down that cable closer to one side, to either side. Now, because it's then got another cable underneath it, it draws the current to either side of the core of the cable. And what that causes is it means that the current is squeezed. So where you'd have a cable this big normally, the current is squeezed to either side, and it's basically not going down the center of the cable anymore. It's pushed to the outer limits, increasing or decreasing the cross-sectional area of your cable and actually increasing the temperature. So again, I'm going to cut it just here, and we're going to quickly wind this up. we'll get set up and then hopefully we can set things on fire. So we're now fully set up. What we have this cable reel plugged straight into the Henley blocks. So we won't have the 13 amp fuse now. So we've already removed one problem that's going to cause a cutout. We do still have the thermal fuse in. And what we've had to do is we had to turn everything off, because what we're going to do, switch the power on and then slowly bring everything in, because there's no switches on this. There's a high chance the thermal cutout is going to cut out. So hopefully before the big dramatic ending, I hope that we get that far today, the thermal cutout might cut out, and what I'll have to do is just quickly take that off, sort it out, put it straight through, and we'll do it again. Let's turn things straight on. We'll go for, let's turn the power on first. That's always a good start. So, right, we've got power now. So we'll go 5 on that heater, 5 on that heater, 2 on that heater. So we're already pulling 23 amps. I don't think that's a problem. Most people, we won't get any build up just yet. It'll take a while. So we won't dilly-dally. We will go straight for another 2. So we're now at 33 amps going through this. Yeah, all going well. 33 amps going through. I don't know if we're going to have any. Yeah, we've got a little bit of build up on the temperature already. We're up to 34 degrees already. You can see the way that the heat is distributed across the reel, which is quite interesting. Yeah, I can't. I thought I could hear a buzz. Right, let's turn that heater on. Another 2. So, to be honest with you, we've got pretty much everything on. I hope this isn't going to be very lackluster. We've got 40 amps going through now. We are building up to 50 amps. Now, again, the maximum we were meant to have is 720 watts. We currently have 40 amps, which is an awful lot more watts than 720. I'm not sure how long it is building up now, so it's 60. I am feeling the heat from my legs because of all the heaters down at the bottom, but about 62. Okay, we'll just leave this to build up for a few minutes. Hopefully we will get some effect. It's surprising. Let's see if we can get any temperature on the actual plug. I think because the outside of the cable reel now, you can see all of the fuses glowing in the plug tops. Oh, there we go. So I don't know if you heard the click. I probably didn't hear the click. There was a tiny little click there, and now everything's turned off. So the thermal cutout, we probably were running 40 amps for probably only about 3 minutes, which is expected. What I'll do quickly is we'll take this all to bits. We'll quickly take the thermal cutout out, and then we were obviously loading it up. So it's obviously, oh shit. Yeah, no, that is hot. That is very hot. So I will literally take the thermal cutout out and then we'll load it up. It may take a little bit of time. I'm thinking that we're gonna have to literally let this build up and let these 2 effects take effect. So we'll quickly take that out and we'll be back. So 80, 90. I would actually say that this isn't going to take as long as I thought. So we're only probably about 2 minutes in, 3 minutes in, we're already at 100 degrees. And as I said, we've got these 2 effects. So it's not like the other cable where we had to keep overloading it because it was going to have air blown over it. This does actually have these 2 effects causing a problem, causing heat build-up because of electromagnetic effects, and also basically just being stacked up onto each other. But you can just call it resistive losses, just to make yourself sound fancy. Right, let's see what we're at now. Oh, we're 112. Okay, so that's pretty good. So I'd say that they are building up. The heat is building. You can see the cables underneath sagging a little bit. We haven't got any smoke yet. I think the Wago, let's have a look at what's going through the Wago. The Wago, if you look at the Wago, look how hot the Wago is. The Wago is actually 125 degrees. And the plug tops, okay, you can just see the fuses just glowing slightly. Oh, I don't know how long. This is 120, 125. Let's get some safety glasses on. Okay, we've had this been going on for about 5 minutes now. The cables were 142. Russ, I think come this side, look. 145. I think the cable's going to start glowing in a second. 146. Yeah, we're definitely very close to the moment that the last cable gave way. I'm not sure if these effects just look at that. That is absolutely glowing, mate. 153. I'm sure that is melting somewhat inside. It's taking it like a champ though. We will just, oh, we're about 160 degrees now. Glowing. Absolutely red hot. Can't see any effect on the cable whatsoever. +160 degrees. Did we just pop? I don't know if that, I don't think we actually had an explosion then. I think we might have just popped the 50 amp. No. It seems as if we have popped the house again. So I will go and sort this little problem out. We are absolutely red hot. That absolutely stinks, but I think because it's like a rubberized cable. Oh, you can see it smoking. We're very close. Right, I'm going to go and see if I can switch the electricity back on and we can continue this. Oh. Okay, so it looks like we had a very disappointing melting of the cable whilst it was off. Or when it did trip out last time, it didn't overload. It must have done a very lackluster pop within the cable. What we'll do quickly is this is very disappointing. I wanted a fire, I wanted an explosion, I wanted melting. But what we've literally just got a poof, which I did say on one of the previous videos. I said sometimes we get an explosion, sometimes we just get a poof. So I'm very, very upset today, or very disappointed, shall I say. Firstly, we had a 13 amp plug top or 13 amp fuse that lied to us. And then now we've just had a very disappointing experiment on an extension reel. What we'll do quickly, we're going to take this to bits, just see just how melted it is. And then we will, next time, I think what we'll do is we'll create this same scenario, but with a different type of flex. One that we know is going to melt. I think this is quite rubberized, this cable. So I think that's why it took so long, and it's probably just melted the cores inside and just blown out with inside itself. Unlike the other flex that completely melted all 3 cores and just took it out in a ball of flames. We'll take this to bits and we'll get to the bottom of it. So you can see just here as we've split it open, ow, that's very hot. The cables are literally just melted right at the core, just there. Oh, it's very spongy. So it was very disappointing. I think this is quite a heavy duty flex because the flex is nowhere near, for 160 degrees, it is nowhere near what I thought it was going to do. So I assume this is quite a heavy duty cable reel. So in conclusion, this week, very lackluster. We didn't have any explosions, or we did, very minor and very concentrated in the reel. We will try, and next week, do this on a different scale, maybe a larger scale, definitely with different cable, probably with some 0.75mm flex. And what we'll do is we'll create a rig on here so that we can keep loading it up with loop after loop after loop. We could even do 100 meters. Let's see. So I'm very sorry, a bit disappointing this week. As I say, next week we'll try to build a bigger reel and actually get some flames and an explosion. Yeah, hopefully with that we'll get an explosion. But if not, we will keep going until we do. So See you then. Right, where's my mic?
Oh shit.